Hello, in this video let us discuss the introduction to inequalities. So in the past we have worked with equations. So equations had equation has equal sign in it. Now, now we will look at inequalities which have these signs less than or equal to, less than, greater or equal to, greater than. So in these questions we will have these four signs as opposed to the equation. And there are few differences that exist when you solve an inequality versus the equation. First of all, when we solve the inequality, we follow the same two-step process that we have for solving equations. The process is summarized by the order of operations, which is PEMDAS, P-E-M-D-A-S, and just like when you solve an equation, when you solve inequality, we follow exactly the same steps. We start at the top and we work our way down and simplify everything that can be simplified. Once we get to the end, we have our expression, our inequality in the simplest form. So at that point we begin to solve. And to solve, we look at it as if x is being hidden by a sequence of operations that need to be undone. And we undo them following the order of operations in reverse. And so working our way backwards, we will clear all the remaining operations, getting x by itself, whatever it happens to be. Now, there are two differences between the equation and inequality. The first one is when we multiply or divide by a negative, we flip the inequality sign. And it only happens if we multiply or divide by something with a minus. It doesn't happen when we have a plus. So the reason for that, is when you have an equation, flipping the equation makes no difference. It still looks exactly the same. But when you have less than or equal to and you flip it, you get greater or equal to. If you have less than and you flip it, you get greater or equal to. Greater than, sorry. And so why is that the case? Well, the reason is that one of the ways we can justify it to ourselves is perhaps that with negative numbers, the larger number is actually smaller. The larger number is smaller. For instance, -8 is considered to be less than -2. So what happens if I have a true statement such as 8 greater than 2, and I do the operation of multiplying both sides by -1, which I can do, that turns into -8 greater than -2. Well, that's a false statement. That is not true. So we have multiplied both sides by -1, which we should be able to do, and then the result is not true anymore. And so to fix it, each time we multiply by a negative, we actually flip the inequality sign and change it to its opposite. So if we change it to -8 less than -2, then it becomes true. And so that is the reason for the procedure for the flipping of the inequality sign each time we multiply or divide by negative. And the reason we do it for the division is because if we divide, let's say we have x divided by -2. Well, that is the same as x multiplied by -half, because multiplying by half, when we multiply fractions, we're multiplying straight across. So -1 times x would be -x, and 1 times 2 is 2, so that's -x over 2. So since dividing by negative is the same as multiplying by a different type of a negative, just a fraction, the flipping of the inequality sign is done in both cases. And then the second difference is that when we find the solution, we have to write it differently. So we write our answer either in interval form or set builder. And we'll talk about both of these ways in a second when we actually practice an actual question. So let's go ahead and do a simple question and see what these operations actually mean. So here is an example. Solve negative 2x plus 8 plus 5 less than or equal to 13. So following the order of operations, we begin with parentheses. There is nothing to do inside the parentheses, so we're done with that bit. The next is exponents. There were no exponents. The next is multiplication and division. There is a multiplication here, so we multiply negative 2 times x, that's negative 2x. Negative 2 times 8 makes negative 16. The rest of the question is unchanged. It is plus 5 less than or equal to 13. So at this point we are done with multiplication, done with division. We're doing addition, subtraction, and there is only one thing that we can actually add, and that's negative 16 plus 5. So we have negative 2x, negative 16 plus 5 is negative 11, less than or equal to 13. At this point we're done with simplifying. There is nothing else to simplify. So we go back to our order of operations, and we have two things to undo. We have a multiplication, which is here, and we have a minus 11. So following the order of operations in reverse, we undo addition and subtraction first. So to undo negative, which we have, we use its inverse, which is plus, so we will be adding to both sides 11. So we have to cancel negative 11, we add 11 to both sides. That does not affect our inequality sign. We get exactly the same inequality sign. Negative 2x less than or equal to 24. Now at this point we do have to undo multiplication by a negative, and to cancel it we have to divide by negative as well. So dividing both ends by negative 2, we get x, then the inequality sign switches because we divided by a negative number. And 24 divided by negative 2 is negative 12. So this is our answer. Now let's talk about how to write it. In the interval notation, we write where the interval begins, where our answer begins, comma, to where the answer ends. And around these two numbers or symbols, we put either parentheses or brackets. And the bracket is put anytime we have the equal sign. So if we have less than or equal to and greater or equal to, we are putting bracket around that number. Anytime we have just less than or greater than, or we're dealing with infinity, we put parentheses. So in our interval notation, here is the visual diagram. This is our x-axis, and somewhere there is x negative 12. And greater or equal to negative 12 is everything to the right of negative 12. So it's all of this space here. Now the negative 12 itself had an equal sign with the inequality, so that's a bracket. I apologize. That's a bracket as opposed to parentheses. So this visual diagram, that's not itself an interval notation, but it helps to, sometimes it may be useful to somebody who's trying to write an interval notation. So at this point, all I do is copy this picture in this notation. So I have a bracket to begin with, then there is minus 12, and there is no end, it goes to plus infinity. So plus infinity is the end, and there is always a parenthesis around infinity. So this is the answer using the interval notation. In a set builder notation, so set builder notation, the set is simply, a set is nothing more than a list of like or similar items. So we could have a set called pets, where we could have our cat, the dog, the horse, whatnot. And the curly parentheses abbreviate the set, and the commas list the elements or the items that belong to the set. So in a set builder notation, we have to write all the places where the answer is true. And the set builder involves curly parentheses, and then there is what is the variable that we used. The unknown was x. So the x, then the vertical line, which is interpreted as such that, and then the condition which has to be met for it to work. And the condition is the same exact as we had in our solution. X must be less than or equal to negative 12. So greater or equal to negative 12. So here is x greater or equal to negative 12. And that is the answer in a set builder notation. And that's it for the introduction to inequalities. In the other video, we will practice solving inequality with double inequality signs. Thanks a lot for your time.